This is lab 4 oscillations. Chris Patel will be going through this experiment here. Basically, it's regarding the spring on oscillating pendulum at the top using the tracker and the glow script code to develop an observational model. Um, we'll go through this later in the slideshow, but I did use the provided video rather than making another one on my own. Now, the goals here of the experiment kind of just touched on this, but the goal of the experiment here is the comparison between the observed motion through the use of the tracker program and analyzing the video and the Web v Python computational model. This will be done through plotting the relative energy changes based on the findings from the tracker program and kind of analyzing the motion, the oscillation motion. Kind of this introductory slide here, the results, which we'll go through later in the analytical part of this video. Both the observed motion and the computational model are similar in representational forms of the original video file. From the calculations done in this lab, the net delta E is 0. The concepts utilized here, kind of just briefly touching on what all formulas and things like that, and concepts and ideas that we're tying in here to this lab. First, primarily Newton's second law, including delta P over delta T, the velocity update formula, which is VF equals VIF net over M plus change of time, and then using that respective velocity update impression on the position update formula. Continuing the concepts, the energy principle here, delta E equals the work on the surroundings, which is the energy principle formula. And we're also going to use the kinetic energy idea through the formula that we know, which is capital K equals 1/2 mv squared. Free body diagram for the lab here, kind of tying everything in from the provided video. You can see you have the little mass of the object in the middle, and then we have the force of the spring in the upwards direction and the force of gravity in the downward direction. I'm kind of showing that here on a free body diagram. Now here's the tracker program that was utilized. You can see the video. Here's the tracker little point of mass that you put in there. The center of the coordinate plane was where the video had told me to align it. Here are all the respective time, X, and Y positions, and then the graph, which we'll go into later, was up here. This just kind of shows you the general setup of the video being brought in, the coordinate plane here, and the table. Let's see. So here's the oscillations viewed as a plot gathered from the steps that I just showed you in the past slide. You can kind of see that oscillating motion completed by the object on the X, as well as the Y. The overall time here was 9.972 seconds, and yeah. So the relative positions of velocities and the respective update formulas are translated into the glow script program. The code will be in the comment section of the YouTube video. For some reason, the screenshot of the computational model was not able to be obtained. I'm not really sure why. It wouldn't translate. The code is in the comment section of the YouTube video. It can be analyzed if needed, but we'll go into all the results later on in the discussion section. Here's the analysis from tracker. The video FPS 11.2 frames per second and 0.095 seconds per each frame. The object's mass gathered from the video that the instructions had told me to was 0.4 kilograms. The time to start was 0, time to finish 9.972 seconds, initial velocity being 0. The equations that had to be coded into the glow script were the spring force formula, the net force formula, the position update formula, and the velocity update formula. Discussion. Conclusion findings from both the glow script and the observational, but comparing the two, both the X position and the Y position versus time graphs from the computational model were supportive and representative of the observed model. Sources of error, as mentioned before, the primary source of error was the fault in the network's ability to translate the observational video, or not the observational video, the glow script file into the slideshow. That being said, the data and discussion show from the findings for comparison of the two. And another source of error could be the lack of the calculation of thermal energy. Answering the question, is the energy principle satisfied? Yes, total net energy is 0. Explanation is provided below. I'm kind of running out of time here. If Future recommendations, thermal energy taken into account, higher quality video for initial observation on through tracker. Other than that, thanks for watching.